Okay, note to self, remember to hit record. Okay, let's move on to question 2. So we're being asked to prove the following. We have a plus b cubed equaling this large amount of stuff. So let's prove the first one. So we have 2 lines. So let's a plus b cubed. Okay? So a plus b cubed can be split into a plus b squared times a plus b. And how we can do this is by n11, where a m plus a to the power of m plus n can be equal to a to the power of m times a to the power of n. And this is where, in this case, a is equal to a plus b, m, n is equal to 2, 1, respectively. Okay. So then let's push this aside, down here, I don't know. So we know what a plus b squared is. We have it in the book, and we proved it earlier, or at least even the book proved it for us. So let's use substitution. So by substitution, we have a squared plus 2ab plus b squared is times our a plus b from above. And then, by our distributivity property, of multiplication, we want to distribute a plus b into our left-hand side. So a positive, 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 a times a squared, a to the power of 3, a cubed. Positive, 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 a times 2ab will be equal to a squared b. Positive, 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 a b squared, a b squared. Positive, positive, bringing in the b now, a squared times b, a squared times b. Positive, positive, 2ab times b equals 2ab squared. Positive, positive, b times b squared is b cubed. And then by simplification, we'll bring down our a cubed, and then we have a squared times b, and we have another one over here, and a factor of 2 and 1, both positive, so we have positive, 2, 1 is free, a squared b. Then we have a times b squared, and another one, positive, 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 a, well, factor of 1, factor of 2, 3, a, b squared. And finally, we have b cubed, and we're bringing that down. So, we are trying to prove that a plus b cubed is equal to a cubed plus 3 a squared times b plus 3 times a b squared plus b cubed. Did we get that? A cubed plus 3 a squared b plus 3 a b squared plus b cubed. It appears so. Now let's prove the second part. a minus b cubed is equal to a cubed minus 3a squared b plus 3a b squared minus b cubed. So we're going to split this to a minus b squared times a minus b by n 11. A to the m plus n is equal to a to the m times a to the n, where a, m, n is equal to a minus b, 2, 1, respectively. And then we know a minus b squared is equal to this, so we're going to substitute it in. So this is by substitution. A squared minus 2ab plus random parenthesis, and jumped in there. I think my brain is splitting apart like a watermelon right now. Okay, a squared minus 2ab plus b squared. We put this in parentheses because we are also still multiplying by a minus b. Now that we have this here, we can use the distributivity property of multiplication to bring in the a and the b. So then, a times a cubed, the a squared is a cubed, positive, positive, okay? Then we have positive minus, minus, a times 2ab is going to be 2a squared b, and then we have positive, positive, so we have positive, a times b squared is simply equal a b squared. Then now we have minus, positive, which will equal minus a squared times b, which will equal a squared times b. We have minus minus, which will be positive, and we have 2ab times b will equal 2ab squared. And then we have minus positive, which will be minus b squared times b is equal to b cubed. And then by simplification, we bring down a cubed, and then we have an a squared times b, 2 places, both minus, so we'll end up in a minus sum. We have a power of 2, a power of 1, not power of 2, we have a factor of 2 and a factor of 1, so we have a factor of 3 in total, a squared of b's. A squared b's. Let me cross those out just to give us some memory that we just used them up. And then we have a b squared, and we have 2 factors, and we have both positive, so our ending will be positive. And we have a factor of 1, factor of 2, that'll be a factor of 3 in total of our a b squareds. And then finally we have our minus b cubed, and we just bring that down to minus b cubed. And if we look above, equals, 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 equals. So check. So we approved proof by identity on both accounts. Okay, that answers problem 2.